guys, so today we are talking about Hess's law again, but here's a different version of it. Yesterday, when we were talking about Hess's law, we were given just enthalpies of certain products and certain reactants, and then we were subtracting the reactants from the products, right? Total enthalpy equals products minus reactants. But with this type of Hess's law problem, they give us an overall reaction, and then they give us a bunch of half reactions. And what we're pretty much doing is we're going to be flipping and manipulating these half reactions to match our overall reaction. And while we're flipping them and manipulating them, we'll have to manipulate these enthalpies as well. And then at the end, we just add them all up. So let's go ahead and get started with an example. This is our overall reaction, and they gave us 3 half reactions. We have a C2H4 that we'll have to match up to at some point, while the H2 will have to match up at some point, and we'll have a C2H6 that we'll have to match up to at some point. Okay, so we'll want these guys to have those reactants on the left and those products on the right. So let's look at our first half reaction here. When I look at this first half reaction, the first thing I see that matches with our overall reaction is this C2H4. Okay, I look at that, it's on the left side just like that, C2H4, so I'm going to leave this one be for now, okay? Again, I'm trying to match it up, the C2H4 is on the left side as our overall, so I'm going to leave that, and I'm not going to change the enthalpy at all whatsoever. So let's go on to the second one. So I go down to the second one, and the first thing I see that kind of matches with our overall is that C2H6, right? It's on the product side, but here it is on the reactant side. So what I'm going to do is I'm going to end up flipping this whole equation here. And when I flip it, guess what it's going to do to my sign over here? It's going to make it opposite. It's going to make it positive. So what I'm going to do is I'm going to go ahead and I'm going to flip this so that it matches my overall reaction. Okay? So we'll have our 7 halves of O2 gas over here. We'll have our C2H6 gas over here. And then I believe it was 3 H2Os and 2 CO2s. And let me double check just to make sure. Yep. So I flipped it. So now this guy is matching our product. And since I flipped it, I'm going to change that negative sign to a positive sign. Okay? Then let's go on to our third reaction. It's got H2O2 and H2O. Hey, our overall reaction has H2. So that matches that. Everything looks good. Now to check our answer, let's make sure that all of our reactants and products in our half reactions cancel out. So again, when we're comparing to the overall reaction, we want these half reactions to be on the same side to match up, okay? And then, when we're done matching everything up, we'll focus on our half reactions and we'll see if everything cancels out to leave us this overall reaction, okay? So let's go ahead and do that. I have 3 O2s on this side and a half O2 on this side, so that makes it 3.5 O2s. Well, I have 3.5 O2s right here. So these guys will cancel out. Cool. Okay, so that's good. 2 CO2, 2 CO2, those guys will cancel out. And something else that wasn't in the overall reaction was these H2Os. I have 3 H2Os here, and I got 1 H2O, 2 H2O there. Hey, look, we're just left with everything that's in our overall reaction. I know I've done this correctly. Okay, so again, when we're starting this problem, we're matching everything in this overall reaction, but when we're checking our problem, we're canceling out things that are the same on both sides. So like we have 2 CO2s here, 2 CO2s there, we cancel them out. Okay, so matching the overall on sides, but then when we check, we're crossing things out on opposite sides. Then, just to find our answer, now we add up all of our enthalpies there. So we'll add them all up and we should get an enthalpy of 136.8 kilojoules per mole, which if I were to ask endothermic or exothermic exothermic, you'd say endothermic because it is positive. Okay, so that is Hess's law, part 2. Now, if there was a situation where we had to double something, we would double our enthalpy, or if we had to half something, we'd half our enthalpy. Let's go ahead and do an example like that next. Alright everybody, here is a new Hess's law problem where again we are going to be trying to match our overall reaction to determine the overall enthalpy of that overall reaction. So we go ahead and we look at this, and I see I got C3H8, 5O2, 3CO2, 4H2O. Let's see if we could get that from all of our half reactions. So I look at C3H8, I look at my half reaction. Hey, C3H8 is in that reaction. The only problem is that it's on the wrong side. So let's go ahead and let's flip that, so now that it will be on the correct side. So C3H8 gas, and I believe it came from 3 carbon solids to 4 H2 gases, and of course, since I flipped that reaction, I'm going to go ahead and I'm going to change this minus to a plus. Okay? We're looking at our next one. It's got a carbon solid, it's got O2 gas, which we have, but it's also got CO2 gas. Okay? CO2 could be multiplied by 3, and O2 could be multiplied by 5. Well, let's see. Do I have something else in my reactions here that have a CO2 or O2? This guy has an O2, so maybe this will play a factor later on with my oxygens. But there are no equations that have CO2 in them. So this is the only thing that can affect CO2. So let's just go ahead and focus on CO2 here. There's 3 CO2s there, 3 CO2, or 1 CO2 there, so we gotta multiply everything by 3, okay, to make it match. So we got a 3 there, we got a 3 there, we got a 3 there. That means I'm going to have to change my enthalpy and times it by 3 as well. Okay? So now our CO2s match up, our O2s, not necessarily, but maybe we could fix that later on with another half reaction. Okay, but at least those CO2s are good because we know there's no other ones in any other half reactions. So let's go to this one. Okay, I got H2O2 and H2O gas, and you might be thinking, hey, we have H2O up here. This is H2O liquid, okay, that is an L. So, we cannot match these up. They're 2 different states, they're totally different. But, the good thing is that, remember we only have 3 O2s here and 1 O2 here. So, let's go ahead and just try to match it to the 5 O2s, right? So we have 4, so in order to get 5, we'll just have to multiply everything by 2 once again. Okay. Well, now we have our 5 O2s, our 3 CO2s, and our 1 C3H8. So now I just got to focus on my H2O liquid, which luckily is in my last reaction. Unfortunately, okay, I don't have enough H2Os and it's on the wrong side. So what I'm going to do is I'm going to go ahead and flip this. Okay, so now H2O liquid is on the correct side, and now I'm going to multiply it by 4. So, again, since I flipped it, I now have to make my enthalpy negative, and since I multiplied it by 4, I have to multiply it by 4 as well. Let's check our answer by now canceling out things that are on opposite sides with our half reactions, okay? I got 3 carbons over here, 3 carbons over here. Adios. I have 4 H2O gases, 4 H2O gases. Adios. Okay? I got 4 hydrogen gases. I got 4 hydrogen gases. Adios. And then I think it looks good from there on out. C3H8, C3H8, 5 O2s, 5 O2s, 3 CO2s, 3 CO2s, 4 H2Os, and 4 H2Os. And our last thing to do is just go ahead and multiply all these out, add them all up, and you should get an enthalpy of negative 2 to 19.9 kilojoules per mole. Which if I were to ask you exothermic or endothermic, you would say exothermic because it's negative, okay? There are situations where you'll have to half them, okay? If you have to half them, right, then you just half the enthalpy as well. There might be a situation where I give you the overall enthalpy, right? Like I might give you negative 2 to 19.9 kilojoules per mole. And I might not give you this guy, okay? Well, you'll just do negative 2 to 19.9 equals all those enthalpies added together, and one of them will be a x, right? So it'd be like x plus negative 393.5 times 3 plus negative 483.6 times 2 plus negative 44 times 4. Okay, you might get a situation like that where they give you the overall and a bunch of half reactions, but they don't give you one of the enthalpies for the other half reaction. You'll just have to do a little bit of algebra to figure that out. Okay guys, that is Hess's Law Part 2. Again, it's just a big puzzle. We're matching everything up to match that overall equation. If you have any questions, let me know, and have a great day.